Password recovery can be an intensive process, especially if you're not using hardware optimized for hash cracking. Today, we're going to look at a free Google AI cloud computing platform to see how we can recover passwords. Colaboratory is a web-based Python environment offered by Google for training artificial intelligence. But thanks to the unbridled access Google provides to this service through a Jupyter Notebook interface, I've written a utility that lets me invoke Linux tools such as HashCat for speedy password recovery, and also a library that allows me to remotely log in over SSH. To follow along with this video, all you're going to need is access to a device with a Google account and the password hash you're trying to recover. In a browser where you're signed into a Google account, start by heading over to my GitHub page at github.com/alexlynd/collabtools and navigate to the Hashcracker Python notebook file. After it opens, you're going to want to go ahead and click on the Open in Collab badge near the top of the page, which should spring you into a Jupyter Notebook on the Colaboratory website. Now, if you've never used Jupyter Notebook before, it's just a Python environment that allows you to format and run different code blocks with the ability to render Markdown, HTML tables, graphs, and various other data visualization tools that make it very suitable and useful for training and visualizing AI data. So for instance, here you can see a previous project I worked on called the Creep Detector, where I utilized some of these features, for example, to map this plot of creeps from a war driving route, which are some Wi-Fi devices we spotted, and also created this table of wireless networks that were spotted on this war driving session. However, today we're going to be using this Jupyter Notebook script I created in order to crack and recover password hashes using a Linux utility called HashCat. But before we get started, you're going to need to know what kind of password hash you're trying to recover and have access to the hash or HashCat compatible file that you want to crack. In my case, I'm going to be demonstrating the common MD5 algorithm, and we're going to start by hashing random generic password for this video. I'm going to go ahead and hash, we're going to go with cats, so hash cats, and pass that over to MD5. So here you can see it creates this weird concoction of letters and numbers into this unique string. So since hashing works as basically a one-way form of encryption, that means in theory, every plaintext string you input into this algorithm is going to produce a unique and vastly different hash compared to the original input, which there should be no way to reverse. So if I were to change this by just one letter and make this bats, you can see that this is substantially different than the original input. However, if I were to run a more common password like password123 and hash it, this might be actually subject to common attacks. So if I can just copy, oh, that's not password123. So if I were to copy this hash, we can actually check against databases like this online MD5 decryptor that have millions of commonplace passwords that have been hashed into their database. So I figure password123 is a fairly common password, so we have a pretty good shot at finding this here. And yes, as you can see, the website was able to decrypt this password, so we can tell that this obviously is not a very safe password to use. While hashing can be used in some cases for password storage, hashing alone obviously isn't secure enough, since anyone with access to like a password dump of a lot of hashed passwords can quickly identify which hashes look the same and therefore correspond to the same password. So they can potentially crack them with a brute force algorithm that targets simple and commonplace passwords. So one solution to this vulnerability is using something called a salt, which is basically a string of random characters that are saved and appended to the end of the hashed password. So to keep today's demonstration simple, I'm going to go ahead and hash cats, but this time we're going to add on a salt of banana. Now, if you're trying to recover a local password, you will usually find both the hash and the salt stored in a file somewhere on your computer. So that would look something like this. You would have the salt saved and a delimiter followed by the salt, which would be banana. However, this demonstration would not work for doing something like attacking online passwords unless you've encountered some sort of data breach or data dump where you have access to these files. So this should only be used solely for personal password recovery. So I'm going to go ahead and copy my hash and note my salt, and we're going to go ahead and head back over to my Google Colab file. I'm going to start by running the first cell, which will clone and install HashCat locally on your Google Colab session, which might take a while to build. So the next thing I'm going to do while that's running is make sure that I have my runtime settings set up correctly. So I'm going to head over to runtime, go to change runtime type, and make sure that hardware accelerator is set to GPU. This will allow HashCat to utilize our computer for full accelerated hash cracking and will offer us a ton of password recovery ability compared to your average computer. After HashCat is installed on our runtime, which you can see from this cell having verified that it ran successfully, I can go ahead and run the next code cell, which is a benchmark test to see how many MD5 hashes HashCat can run through in a second. So I'm going to go ahead and scroll down and we can run this code block. But the first thing I want to do is change this parameter here, TAC_M, to make sure it's using the correct hash type. So right now it's set to 2500, which is actually a WPA or Wi-Fi hash. So I can head over to the reference site on HashCat to check which hash is the correct one for MD5, and I'll leave the link to this in the description below. So since we're using a salted MD5 password, I can see that the hash mode that we want to use is hash mode type 10. So I'm going to go ahead and copy this and head back to our notebook. So I'm going to run HashCat TAC_M 10, W4 for workload profile 4, and then TAC_B for benchmark. So as you can see, it clocks in at around 7,500 millihashes per second, which is crazy fast. But if I run the same command on my computer, we'll see just how puny my computing power is compared to these servers that are tuned for training AI. So I'm going to go ahead and copy this command, HashCat TAC_M 10 workload 4 benchmark, and I'm going to go ahead and paste this in my terminal. Contact force. And now we're going to wait for this to run. So as you can see, HashCat comes in at just thousands of hashes per second on my computer, which is a mere fraction of the power Colab offers, meaning that if you wanted to do intensive recovery for a complex password you've created, then this will work great for you without having to buy extra hardware like a GPU or a specialized computer for hash cracking. So now that we have our hash and salt, the next step is to just assemble a word list of probable passwords that we want to test against. So heading over to the Colab script I wrote, you can scroll down to the word list section. And here you can see I've included a default top 10,000 password list from this GitHub repository from Daniel Messler's sec lists. However, I also included the option to upload your own word list to the runtime environment and even permanently save it to Google Drive if you want to create a customized one, since uploaded files will delete after a limited runtime session. So I'm going to go ahead and download our default word list. And as you can see, it did not download successfully because I forgot to put this in quotes, which I will fix on the GitHub repository. But I'm going to go ahead and fix that real quick right now. And if I run this again, we should be good to go. Sweet. So after the password list downloads, we're now ready to start testing our password against the word list. So we should have a pretty good shot at this since we know it's only one word and we aren't running any fancy combination attacks. So I'm going to go ahead and copy the hash that we want to crack, which is cat's banana, and make sure to note that the salt that we're going to be using is banana. So heading back to the Colab file, I'm actually going to scroll down all the way to the bottom and add a new code block. So what I want to do is save the hash and the salt into a new text file. So the way I'm going to do that is I'm going to run a Linux command called echo. So I'm going to run echo quotation marks, and I'm going to paste the hash that I just copied and use a delimiter to separate it from the salt. So I'm going to use colon banana. And the last step I want to do is pipe this into an output file, which will be password.txt. Now, one more thing you have to note before running Linux commands through Jupyter Notebook is that Jupyter Notebook will try to automatically parse this as a Python command. So if I want to run a Linux command through here, I have to add an exclamation mark at the beginning. So exclamation mark, echo all this text into this text file. And if I run that, it should be good. Yep, so we have a check mark. Finally, I'm going to take a look at the cell just above the one I created, which should be able to crack our password. So I'm going to want to supplement the password list and the password hash that I want to crack. So first, I'm going to swap out password.txt for the file to crack. And finally, I'm going to plug the word list, which is top 10,000.txt. Also, another thing to note is make sure you have the correct hash type set. So earlier, we determined that we want to crack an MD5 hash with a salt. So I'm going to change this to type 10. And we're going to go ahead and run this. So as you can see, in just less than a few seconds, the password was already cracked. So you can see the hash we supplied and the salt and the original password that we supplied, which is cats. HashCat was able to successfully parse through the word list we supplied and hash it with the provided salt in order to crack the encrypted password. But for more complex passwords, however, you'll have to look into creating a more targeted word list, which might include a combination of words or numbers. But in future videos, I'll go into more details about advanced password recovery techniques through HashCat, and also how you can use this script to potentially recover trickier passwords, like for wireless networks. While there are some drawbacks to using Google Colab, like needing access to the internet and also the limited runtime access, we're going to show you in future videos some workarounds for this problem, and also how you can remotely log in over SSH. If you enjoyed this video, please let us know in the comments what other hacks and demonstrations you'd like to see, and stay subscribed for more fresh hacking content. If you have any questions, you can always reach out to me on Twitter at AlexLynd. Thanks for watching, and we'll see you next time.
Thanks for supporting Hack5. Find all our shows, community, and pentest products at hack5.org.